Hey guys, welcome to Tips and Tricks. This is Viren here.
This is my video number 5. Again, these are the basic ground rules or some information for you. Feel free to pause and have a look at this. Alright, I'm gonna jump straight to slide number 2. So these are the things that we will cover in this video. What is a token ring? What is a NIC card? What is a bit nibble byte? And what is a MAC address? Okay. So token ring is by IBM. I'm just I can just correct that here. So this is by IBM. So token ring is also a LAN technology which we saw just like Ethernet in the earlier video. Now Ethernet used CCNA CD to ensure that there is no collision when all the stations connected or all the PCs connected are transmitting. Similarly, in token ring, they have something called as a token or a token algorithm, which ensures that there is no collision. So let me just bring up the scratchpad and show you how it works. So in token ring, let's say we have a PC A, a PC B, C and D. So what happens is these PCs are arranged in a ring fashion, and that is why it's called token ring. And then there is something called as a token which keeps on moving between all these PCs. That's why it is called token ring. And whoever wants to transmit or send the information, that PC or host or node needs to have that token. Without the token, the station cannot transmit. So let's say B wants to transmit some information to D. The moment B gets the token, it will put on the data onto the token and also the destination address of D, and then pass on the token to C. But C sees onto the token that the destination address is not meant for it, so it will pass on to D. Now D sees the destination address and sees that okay, it is mine. It accepts the data and then passes on the token to A. A again sees the token and sees that there is nothing meant for it on the token, and then passes on the token to B. Now B sees the token and comes to know that whatever information it sent to D, it has been received by D. So that is how it works. So the only person who can transfer, or the only station who can transmit is the station which has the token, and that is how the collision is avoided in this technology. Now the other thing that I wanted to tell you is this technology is defined by IEEE, something called as Institute of Electrical and Electronics Engineers. This is a body which standardizes all the communications or protocols pertaining to network communications. So they have defined this network, this topology in the standard 802.5. Now I missed in my earlier video, we talked about Ethernet, and I did not talk about what is the standard defined by IEEE for Ethernet. And for Ethernet, the standard defined by IEEE is 802.3. So the moment you see 802.3, you should know that okay, this technology uses CCNA CD. The moment you see 802.5, you should know that this uses token ring. And the reason I'm saying this is there are small variants in each standard. So let's say we have other standards like 802.3Z, 802.3A. These are all Ethernet variants, but the base technology is still 802.3, that is CCNA CD. Similarly, token ring may have other variations, but the base technology 802.5 will let us know that this is basically a token ring functionality. Similarly, just to let you know, in wireless you should have seen when you buy phones, they specify in Wi-Fi 802.8 802.A or 802.B, something like that. So these are wireless standards. Alright, let's move on to the slides. So again, I've already explained you this on the Scratchpad. I still wanted to come up with this PPT, so that will help you. Just go through it. I've already explained this. Alright, let's see what is a NIC card. So a NIC card, which is a short form for network interface card, is basically a hardware component that allows your computers to connect to the network. So this is a very critical component, and a NIC card may be used for both wired and wireless communications. So let me just bring up the Scratchpad. So all this while we saw that basically all the PCs, I'm sorry, A, B, C and D, these are all getting connected via the cables or wirelessly, but they still need to have a network interface card for this connectivity, and that is why its name is network interface, because it is giving a network connectivity to everyone. So it is also called as the LAN card because it is giving you this LAN, local area connectivity. Now I'll explain you, although it's a very I could have ignored it, the Ethernet card. Now we just saw that for this LAN connectivity, between all these, we could have used Ethernet, which uses CCNA CD, and we could also use token ring, which we just saw now. But if you see in my presentation, I'm saying that this is also called as Ethernet card, and the reason people called it that it as Ethernet card is Ethernet was so predominant for this LAN connectivity, and now it is very predominant. I doubt if anybody is using token ring for LAN connectivity. It is all Ethernet, and that is why the moment people talk about the LAN technology, they assume that it has to be Ethernet. Nobody thinks that even token ring will be there, would be there in their environment. There is another technology called as FDDI, which stands for fiber distributed data interface, which also uses token ring methodology or functionality. But again, we will not look into all those in detail, otherwise we'll just go off the track. So we just saw that these NIC cards are very important to give this connectivity, and I'm just going to show you what this NIC card looks like. So this is a NIC card which is fixed onto the motherboard through these PCI slots. And what are these PCI slots? I'll just give a point here. It's basically stands for peripheral component interconnect. This is basically a technology to connect various components onto the motherboard, and that is why it is called peripheral component. So you should you were able to connect a sound card or a graphics card and all those things via this slot. This was invented by Intel in 1992. These kind of slots are slowly fading out, and you don't have these kind of network cards also these days. I mean, it's still available in the market, but nowadays these NIC cards are basically embedded onto the motherboard itself. So anyways, if you see, this is a NIC card, you see this is our RJ45 connector to give you that connectivity in the LAN environment, and this is a wireless NIC or a wireless card. So if you remember in my video number 2, I explained that WLAN, that is a wireless LAN, I could just move around with my laptop in my office and still get connectivity to the network. That is possible because my laptop, apart from having this NIC card, is also having this wireless card. So when I'm not at my desk and getting connectivity through this RJ45, I'm getting connectivity through this wireless card. Let me just give you a sneak peek. Now I just went into my device manager. You do a right click on my computer, go to properties, and then go to device manager, which gives you a brief of what are the devices in your laptop or PC. Now if you see here, the first one is my VPN connectivity adapter. The second one is my normal NIC, which is the RJ45, which is your Intel Giga network connection. That is the normally Ethernet connectivity. The third one, which says Intel Centrino Advanced N. Now that is my wireless connector adapter in my laptop. So the moment I'm off the desk and roaming around an office, I can still get connectivity to my office network through this wireless adapter. Alright, now let's move on to what is a bit, nibble and a byte. So as we saw right in the very first video, that computers understand zeros and ones and nothing else. It's all zeros and ones in the end. So and I've mentioned digital signal also here. So let me just bring up my scratch pad. Okay, clear it off. So you know that in binary there is either a 0 or a 1, which can either be made up of an electrical signal, oh man, so bad handwriting, or it can also be made up of a digital signal, which is nothing but light waves. That is what the standard is nowadays, more or less everywhere, to have digital signals rather than electrical signals. So this is a single bit, either a 0 or a 1. So what is a nibble? A 0, a combination of 4. These are all nibbles. This is a combination of 4. A byte is a combination of 8 bits. Can be anything. So these are all bytes. Now I just wanted to bring it to your attention that the IP address that we see is something like 192.65.54.3. This is a 32-bit address. So each dot separates 8 bits. So this is an 8-bit, this is an 8-bit. So this is together a 32-bit address. Remember that IP address is a virtual address, and you know why. We'll get into the details later. Okay. Now, what is a MAC address? The MAC address stands for Medium Access Control Address. Now, this is also called as a physical address, burned-in address, or a hardware address. Okay. So let's bring up my scratch pad again. So now we saw the connectivity between all the PCs, and we know that the connectivity is happening because of the IP address that I just mentioned here. But this IP address, let's say the IP address that I just showed belongs to the whole machine B. What I can do is I can just cancel it and I can assign the same IP address to machine C. So this is not a fixed address, but the MAC address is something which is a fixed address. So like I said, all these machines have a NIC card, and that NIC card has a address which is called as a MAC address, Medium Access Control. So the machine B will have a MAC address something like AABB blah blah blah. Similarly, C will have a MAC address. Now these MAC addresses will not change. So you saw that I can assign the IP address to any machine, but the hardware address is unique for every machine in the world, every device in fact. And whether it's an Avaya phone, Cisco phone, or your computer or a laptop, so the NIC or the medium MAC card or the MAC address, I'm sorry, that is assigned is unique for everything in the world. And how could they attain it? You can just see it here. This is basically a 48-bit address or a 12-digit hexadecimal. The format is something like this. manufacturer, and then serial number. So I can give you a small example of this. Let me just bring up the scratch pad. So let's say Cisco will give all the addresses to their NICs, to their NIC cards, or to their systems, something like 00AA BC. Now the first part, if you see, these are the first 24 bits or 8 bytes. You remember, 1 byte is 8 bits, I just told you. So first 24 bits is something called as OUI, organizationally unique identifier. So this will be unique for every vendor. So let's say this belongs to Cisco. I'm just giving an example. Now the next part of the 24 bits is unique to that particular NIC. So let's say 000001. So next NIC card that they will make, they will rename it same, but this may change, and then they'll go to 3, 4 and whatever, then this will become 100, something like that. So that is how it is designed, that the MAC address for every communicating device is unique in the entire world, cannot be same. And that is the reason it is also called as the physical address and the burned in address. That means it cannot be changed, or the hardware address. So the other thing that I wanted to tell you is we need to know the conversions between the binary hexadecimal and the decimals, from the exam point of view. So let me just bring up the scratch pad and give you a very sneak peek. I guess I will do another video on this. So let's say you have a hexadecimal address of 57. Okay, I need to clean it off. So let's say you have this byte, 1 byte, which is something like this. So this is in binary. Okay, even before that, let me just tell you, in binary we have just a 0 and a 1. So what is the base? We just have 2 digits, so the base is at 2. In decimal system we have numbers from 0 to 9, which is 10, so we have a base of 10. So in hexadecimal we have a base of 16. And how is that? Because after 9 it starts like A, B, C, D, E and F, so which is another 6 numbers. So 10 plus 6, 16. That's how the base of hexadecimal is 16. So the reason I'm talking about the conversions, it's important from exam point of view. So let's say they will give you something like this in the exam, that this is the binary value. What is the equivalent of this in hexadecimal? So you should know, you should divide when you're converting from binary to a base of hexadecimal. What you should do is you should divide your byte into nibbles. So I'm going to divide it. So you've got 4 this side, you've got 4 this side, you've got 2 nibbles. Now on this side it's all zeros, so it will become a 0. On this side it starts something like this, 0 1 0 1. So the first one is 2 raised to 0. Remember, this is a binary. Second is 2 raised to 1. Third part is 2 raised to 2, 2 raised to 3. That is how it proceeds, but only till here. We start once again on the next number. So the first part here is 2 raised to 0 is 1, 2 raised to 1 is 2, but this bit is off, so we will not count this. 2 raised to 2 is 4, and that bit is on, it is 1. 2 raised to 3 is 6, but that is also on, so we will not count this. So we will just count the bits that are on, which are 1. So we will count this and we will count this. So it is 5, and this is 0. So 0 is not counted. So that is why you can say the answer is this value in hexadecimal is 5. Alright, so I'm gonna do additional video on this, and give you guys a link here to go to that particular video and learn all the conversions which are important from exam point of view. And it may just appear on the exam for 1 or 2 marks, but believe me, I gave my CCNA in 2 parts, which I shouldn't have done. I should have given it in a one go. When I gave my second exam, the passing is something like 825 out of 1000, and the first time I scored 816 or 17. So maybe I just failed by maybe just 1 mark. So this may appear maybe just for 1 or 2 marks on the exam, but this is very important. So just go to that link. I'm gonna put that link here somewhere here, and go to that link and see how all the conversions are done. Alright, so with this we come to an end of video number 5. I'm gonna do video number 6 with some more basics, like as to what is a port, what is a socket, some cable standards and connector standards, and I think we should be good after that. And we should get into what is a switch, what is a bridge, what is a switch, what is a router, and then it gets more interesting after that. So again, thank you for watching this video. Stay tuned for my next video. Thank you. Bye bye.